Today, we're going to break down a really powerful scientific tool called RPQ. For anyone who works with data from a microscope, this thing is an absolute game changer. So let's just dive right in.
Okay, so picture this. You're a scientist, you're staring at your computer screen, and it is just swarming with thousands of tiny glowing particles all moving around. And your job is to count them. Not just once, but in every single frame of a video that could go on for hours. I mean, how on earth do you even begin to tackle that without it taking, months of your life?
And this isn't just some made-up scenario. This is a real, legitimate bottleneck in scientific research. For way too long, the slowest part of a really brilliant experiment wasn't the science itself, it was the incredibly tedious job of just counting things up at the end. That manual work literally slows down the speed of discovery. So you've basically got two paths. There's the old way, manual counting. It's just agonizingly slow. And you know what's worse? It's subjective. What one researcher calls a particle, another might call a blurry spot. It's just not consistent. And then there's the dream of automation. A system that isn't just ridiculously fast, but is perfectly objective and gives you the exact same result every single time. And that right there brings us to the solution we're talking about today. It's a tool called Red Particle Quantification, or just RPQ for short. And it was designed for one purpose, to completely demolish that counting bottleneck. So what is RPQ, really? Well, at its heart, it's a clever bit of code, a Python workflow that runs inside what's called a Jupyter notebook, which is basically like a digital lab notebook for scientists. And its mission is super specific. Find and count every single red glowing particle it sees in a video file. That's it. And here's the play-by-play of what it does. First, it scans the video, frame by frame, and filters everything out that isn't red. Then, it uses something called blob detection, which is really just a smart way of finding distinct, circular-ish shapes. It counts those blobs in every frame, and then, at the very end, it spits out all the goodies, the raw data in a spreadsheet, and a brand new video with little circles drawn around everything it counted, so you have visual proof. Now, you might be thinking a tool this powerful has got to be complicated to use, right? But the real genius of RPQ is how simple it is. The entire workflow is boiled down into just 3 really straightforward steps. Seriously, it's this easy. Step 1, you just load your video file. Step 2, and this is the important one, you tune and preview. Basically, you adjust some settings on a single frame to teach the software what it should be looking for. And step 3, you just hit Run Analysis and go grab a coffee while the computer does all the heavy lifting. Okay, let's focus on that second step, tune and preview, because this is really where the magic happens. See, this isn't about some AI just taking over. No way. This is about the scientists using their own expertise to train the software, to tell it exactly what counts as a particle in their specific experiment. So how do you train it? Well, first up is color. You set the red dominance ratio to tell the software, hey, I don't want just bright spots, I need spots that are overwhelmingly red. Then you set a minimum red intensity, which is like saying, and while you're at it, ignore any of that faint, fuzzy background noise that isn't a real particle. Next, you tune for size. This part is great. You set a minimum particle area to throw out any tiny little specks of digital junk. Then you set a maximum particle area to make sure it ignores big smudges or clumps of cells. It's literally like setting up a bouncer at the door for your data. You're too small, you can't come in. You're too big, you're not on the list. And finally, you dial in the sensitivity. The log threshold is basically the main sensitivity knob. You turn it down, it gets better at finding fainter particles. But the really clever part is the robustness factor. This thing lets the sensitivity automatically adapt if, say, the lighting in the video flickers a bit. It ensures you get a consistent, reliable count from beginning to end. Okay, so once all that tuning is done, the researcher is ready to go from just a bunch of pixels to actual hard data. This is the moment where all that careful setup starts to pay off big time. And it all comes down to a single click. The parameters are locked in, the scientist hits Run Analysis, and the software just takes off, churning through the entire video, frame by painstaking frame, all by itself. And when it finishes its work, RPQ gives you 3 incredibly useful files. First, the main event, a spreadsheet showing you the particle count over time. Second, a super detailed file with stats on every single particle it found, its size, its position, you name it. And third, that annotated video, which is so important for visually confirming that yes, the software counted exactly what you wanted it to count. And this, right here,
is the whole point. As the manual itself says, this data reveals the kinetics of what's happening. It's not just about a final number. It's about the story over time. Are particles showing up all at once, or is it a gradual buildup? Does the reaction speed up? Does it slow down? Answering those questions, that's how you make a breakthrough.
So let's just zoom out for a second and think about the big picture here. Why is a tool like RPQs so important? Well, because automating all that tedious work isn't just about saving a few hours. It's about fundamentally accelerating the pace of science itself.
When you boil it all down, the value of a tool like RPQ comes down to three things that are absolutely critical in science. First, speed, turning days or even weeks of manual work into just minutes of a computer's time. Second, objectivity. A computer doesn't have an opinion, it gives you an unbiased, consistent count every time. And maybe most importantly, reproducibility. Another scientist halfway across the world can take your video, use your exact same settings, and get the exact same results. That is the absolute bedrock of trustworthy science.
And that kind of leaves us with this one final, really exciting thought. When data analysis, the most boring, tedious part of the process, is no longer the thing holding you back, what new discoveries are out there, just waiting to be unlocked? What incredible new science can we do now?